Body, mastermind here again. So today we're talking about nomenclature of carbonyls. But before that, let's introduce what carbonyls are. Carbonyls are a family of organic compounds that are characterized by the CO group, C double bond O group. And typically in chemistry, there are two major groups of carbonyls, or some people call it carbonyl, it doesn't really matter. Carbonyls, and they include the alkanals, formerly called aldehydes, and then we have the alkanone, formerly called the ketones. Now, these are carbonyls, and that's because they contain CO group in their structure. So today, we're going to talk about some important features of these two functional groups, and then nomenclature for them. So we'll pick this one first. So let's start with aldehydes. Aldehydes or alkanals, they are a family of organic compounds that are characterized by the RCHO functional group, RCOH functional group. Some textbook will call it, I like calling RCHO. This arrow here can be hydrogen or alkyl group. Alkyl group. Now, and this CO represents the carbonyl group. Now, another important thing you need to know is that this carbonyl group, the carbonyl group of alkanals is always at the terminal. Is always at the terminal carbon. At the terminal carbon. Now, and the word terminal in English, it means end, the first carbon or the last carbon. Now, another thing you need to know is that the general formula of alkanals are the general molecular formula for alkanal is CnH2n plus 1 CHO. This is written in most textbooks as the general molecular formula. The next important thing you need to know is that the carbonyl carbon in an alkanal is sp2 hybridized. Carbonyl carbon is sp2 hybridized. And then the next one I need to know is that alkanals, or the carbon in alkanals, have a trigonal planar shape. Yes, the carbons in an alkanal has trigonal planar shape. Another important thing you also need to know is that alkanals are the most reactive carbonyls. And generally, all carbonyls undergo nucleophilic addition, or we can call it attack. And this is because of the presence of an electrophilic carbon. The carbon in an alkanal is electrophilic, that it can accept a pair of electrons. So it means that it can react with nucleophiles, which can donate a pair of electrons. So they can undergo that reaction due to the presence of an electrophilic carbon. So this is basically the most important general characteristics that you need to know about alkanals for the basic level, at least for the basic level. And that part, E part, is very important because majority of the reactions on our go has one or two things to do with nucleophilic attack towards the hydrophilic carbon. So now let's go straight into the nomenclature of alkanals. It follows the normal general EPAC nomenclature that I've been saying in my videos on alkane, and alkyne. You can check my catalog, you get the general rule, but there are some specific ones that are unique to alkanals, and which is the carbonyl carbon. The carbonyl carbon must be taken as the first carbon. The first carbon of an alkyne. Every other thing remains the same. The subsequent group must be named in alphabetical order and like that. But the goal here is that how can you notice an alkyne is that the carbonyl carbon, that's the CO carbon, must be at the terminal. That's the end, the first carbon or the last carbon. And that carbon must take number 1 because the smallest number that the carbon can take in a chain is number 1. So, and that's why most times when naming an alkyne, most people don't put number because you believe that an alkyne must be at the terminal, and someone don't just write N as the prefix. So we'll draw some structures from the fissure to the condensed to the skeletal, and I'll give you, few to try out to see if you can understand the nomenclature of alkanals. 5 lovely structure of alkanals ranging from the fissure, open chain to the condensed and to the skeletal form. So as usual, I'll name, what I'll do is this, I'll name this one, the first 2, then I'll leave the third one for you to see if you can name it, and then I will name the fourth one and leave the fifth one for the viewers to see if you can name it as a form of practice. So here, A. So the first thing is, why is A an alkanal? Now A is an alkanal because the carbonyl carbon is at the terminal. At the terminal, that's at the last, it's at the end. It doesn't necessarily have to be the last carbon. Now, so automatically it means that carbon must bear the least possible number, which is number 1 around the chain. So you must number it like this: 1, 2, 3, 4, 5, 6, 7. This is your left hand side, and this is your right hand side, like I always do. Now the same reason why we are numbering from right to left is because the carbonyl carbon is at the last carbon toward the right. So you must give it the least possible number, count the chain. So this is the chain. Now 7 carbon is hept. Now, is there a substance group here? Is there something that is here that is not carbon or hydrogen, apart from the oxygen that is here? There is none. So there is no substitution here. So the name is going to be hepan 1 al. As I usually say, the IPAC role states the parent's name, the position, and the functional group. But some textbooks might just call this thing N-heptanal. Now, it is called N-heptanal because the N represents the terminal position. So as simple as that. Now, for B, I've told you that anytime you have a condensed form, the best way to do it for beginners level is to draw it out. So I've drawn condensed form in my videos on alkene, and alkene. So let's draw it together. Starting from the left hand side, this is your left as usual, and this is your right as usual. So the left hand side, what we have here is CH3, the group. So CH3. Remember, in organic chemistry, there is no order. Just make sure the bonds are correct. What you have here is CHBr, the group. So we have CH, and we have Br. You can decide to put your Br on top, doesn't really matter. The next group here is CH2. Now the next group here is CHCl. Before every carbon, you have a group. So we have CHCl, Cl. The next group here is CH2, CH2. And then the next group is CHO, which is a functional group, which is written as this, or which can be written as this C double bond OH. So this is what we have as a chain. Now, as usual, for it to be an alkanal, the carbon that bears O, CO must give number one, like I gave you rule. So this carbon must take number one. So we must count this as 1, 2, 3, 4, 5, and 6 as the chain. So this is the chain. Every other thing. Now we'll check for substitution. Now look at this structure. We have bromine and we have chlorine here. So they are not carbon or hydrogen. So they are substitution. Now in alphabetical order, we must name substituent group first. So we have bromine and we have chlorine. So B comes before C. So bromine is on number 5, on carbon 5. So it's going to be, as usual, 5 bromo. Remember, I use hyphen to separate numbers and alphabet. And then, what carbon do you have chlorine? Carbon 3. So it's going to be 3 chloro. Now, is there anything else here that is a substitution? I don't think so. So how many carbon is the parent is in longest chain? 6 carbon. So remember, hyper code is parent's name, position, and functional group. So what's the parent name? The parent name is for 6 carbon is hex, as in hexanal. So it's going to be hexan. What's the position as usual? 1. And what is the functional group? Remember, you can also call it N-hexanal. So this is the name. This is hyper nomenclature for this structure. So now, using this idea, feel free to pause the video and try the third structure. Pause the video and try the third structure. Let me give you some time to do this. Let me leave that space and come to the fourth one. Now, the fourth structure here, this is a skeletal structure. And why is it called a skeletal structure? Because you're not seeing the carbon or hydrogen. You're just seeing lines. Some textbooks call it line structure. Doesn't matter. So as usual, the carbon that bears this double bond must be given the least possible number, must give number 1. So we must number it as this. We have 1, 2, 3, 4, 5, 6, 7, 8. And what I always do now, I just located the longest continuous carbon chain that bears this functional group. The longest chain is 8. You can decide to count in all directions. We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Remember, every dot is a carbon. What you see here is the carbon that's attached to this O. So the longest chain is 8 carbon. Now, every structure that is not part of the longest continuous chain is seen as an attachment. So how many structures do we not have as part of the longest chain here? We have this, and what? This. That would be 4 structures that are not part of the longest continuous chain. And what are all of these structures? They are all methyl group. I have told you that a line attached to just one dot, as you see here, represents CH3. When a dot is attached to just one line, it's CH3. So we have what you have here is CH3, 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 and CH3. So we have 4 methyl group or 4 methyl group. So on the chain. Apart from those 4 methyl group, is there anything else that is not part of the longest continuous chain? As you can see, there is nothing more. So remember, you must name substitution or attachment group first. And what are their position? We have 3, 4, 5, 6. So it's going to be 3, 4, 5, 5, 6. They are 4, right? So the prefix for 4 is tetra. So tetra methyl, because it's a 4 methyl group. Now, is there any other substitution here or attachment group? No. So the parent chain has 8 carbon. And what is the name for 8 carbon? Oct, as in octan. So it's going to be octane. What's position 1 or like I've been doing so far, N-octanol. Alright. Now feel free to pause the video and try this one too. Now let's come back to structure C. I will leave this one for the viewers to see if they can name. Structure C, we have a condensed form, and as usual, I have told you that when you have a condensed form, draw it out. It makes your work very easy. So what we have, let's start from the left hand side and to the right hand side. From the left hand side, we have CH2Cl. So we have CH2 and we have Cl. This group. The next group is CH2, which is this CH2. The next group is CH2, which is this CH2. The next group is CHI, which is this CHI. The next group is CH2, CH2. And the next group is CHO, C double bond OH. This is the straight chain form of this structure. Now you must get the carbon that has a double bond the least possible number. So that carbon must take number 1. So let's number the chain. We have 1, 2, 3, 4, 5, 6. So we have 6 carbon in the longest continuous chain. Now the next thing we'll do, we'll check for substitution or attachment. Now if you check here, what is in this structure that is not carbon or hydrogen? We have chlorine here, right? And it's on carbon 6. So you must name attachment group first according to the rule that we're doing so far. So it's going to be, the name of this is going to be 6-chloro, as in chlorine attached carbon 6. Now is there anything else here that is a substitution? Yes, we have iodine on carbon 3. So 6-chloro, iodine on carbon 3, so it's going to be 3-iodo, right? Iodine as in iodine, and then 6 carbon is hex as the parent name. So it's going to be hexane 1-al or simply N-hexanal. So now I'll leave this fifth structure to the viewers. Feel free to comment the answers in the comment section. By the way, this structure you see here is an aromatic carbon, a mathematical structure attached to a carbon, and it's called a phenyl group or phenyl group. So feel free to write the correct name of this structure in the comment section. So that's about it for our handout. Thank you for your time. Thank you for your patience. Thank you for watching this video. I remain mastermind of M-Mind Science. Have a good day.